drew the player. 15 controllers, 2 estimators, a buffer that is really a list. The interviewer nods. And then the round changes. Because every question from here is the same question wearing a different hat. Not how does it work? How would you know? 10 follow-ups. This is the round that decides it. First one, and it is the one I promised you. A user drags to 17 minutes. Nothing is buffered there. What happens? The junior answer is, it downloads that part and plays it.
That is not wrong. It is just not an answer.
The interviewer wants the 4 things that happen before a single new byte arrives. 1. The in-flight fragment gets abandoned. You are fetching segment 12. Nobody wants segment 12 now. 2. The player looks at buffered, and it is a list of ranges. 17 minutes is in none of them. 3. It has to make room. Source buffer.remove on the ranges furthest from where you just landed. 4. Only now does it ask the network for anything. And here is the detail that separates the answers. You cannot start decoding at 17 minutes. You can only start at a keyframe. So the player does not fetch the segment you asked for. It fetches the segment that contains the nearest keyframe before you. Which is why seeking backwards feels cheaper than seeking forwards. Backwards, the keyframe you need is often still sitting in the buffer. Forwards, it never is. Put that on the diagram you ended the last video with. Everything I just described happens between 2 boxes. The buffer controller and the source buffers underneath it. The loader does not even know you seeked. It gets told what to fetch, like always. And whether 2 ranges count as 1 is a tolerance. 1/10 of a second. Land in a gap smaller than that, and the player treats it as continuous. Land in one larger, and you stall. Your seek is a range query against a list you do not control. Second. Same player. Now the content is licensed, and the studio wants it protected. What changes? Bring the machine back up, because there is something wrong with it. In V1, I read you 15 controllers, and one of them was called encrypted media. It is not on the diagram. Look. 15 boxes, and none of them is that one.
I drew the player I explained, not the player you would ship.
So let us add the box, and then let us pay for it. In the census, you saw a controller called encrypted media. This is that. The browser API is EME, encrypted media extensions. And it is not a decoder.
It is a negotiator.
Your player asks the browser, can you do Widevine? The browser answers with what it is willing to do. The content arrives encrypted. The browser raises an event that says, I need a key for this. Your code takes that request, posts it to a license server, and hands the response back. At no point does your JavaScript see the key. That is the entire design. And now the thing an interviewer is actually listening for. That round trip happens before frame 1. A different host. A different TLS handshake. Often a different continent. Call it 200 milliseconds on a good day. You spent V1 fighting for a 500 millisecond first frame. DRM just took 40% of it. Encrypted content does not start slower by accident. It starts slower by architecture. One more thing worth knowing. Widevine has levels. L1 means the decryption happens in hardware the browser cannot reach. L3 means it happens in software. Studios tie resolution to the level, which is why the same account gets 4K on a TV and 720 on a laptop.
That is not your player being cheap. That is your laptop failing a trust check.
Third, and this is the one that ends most rounds badly. It works on your machine. How do you know it works for 1 million people? The trap is to answer with server metrics. Uptime, error rate, cache hit ratio.
All green, while the video stutters.
Those measure your delivery. They do not measure anyone's experience. There are 4 numbers, and you should be able to say them in order. Time to first frame. From the click to the first pixel. Not to the request. To the pixel. Rebuffer ratio. Seconds spent stalled, divided by seconds spent watching. Under 0.5% is healthy. Over 2, people leave. Bitrate weighted average. Not what you offered. What actually played, weighted by how long it played. And exits before video start. The ones who never saw anything at all. That last one is the honest metric, and it is the one that gets dropped. A viewer who gives up during startup never fires a playback event. Your dashboard is built out of the sessions that survived. If you only measure people who watched, you have measured the ones who did not have this problem. So, events from the client, not the server. Sampled, batched, fired on a timer and on page hide. Fire and forget. A dropped analytics beacon is not worth a millisecond of playback. And this is where the deeper problem shows its face. Everything in V1 was a guess. This is how you find out which guesses were good ones. Fourth, the product manager wants captions. You said the word twice in V1 and never explained it. Let us fix that. 2 formats you will meet. WebVTT is a text file with timestamps and a bit of styling. It is what the web actually uses. TTML is XML. It is what broadcast hands you, and it can express things WTT cannot. You ship WTT, and you convert TTML at packaging time. But the format is not the question. Here is the question. A caption is not a fetching problem. It is a rendering problem. Native track elements are easy, and you cannot style them properly across browsers. So every serious player parses the cues itself and draws them in the DOM. Which means you now own line breaking, positioning, safe areas, and the fact that a caption must never cover a face. And one thing juniors never mention. Forced narrative subtitles. When a character speaks a different language, you show that line to everyone, even with subtitles switched off. It is a flag on the track, not a separate file.
Miss it, and half your audience watches an untranslated scene in silence.
Fifth, download for offline. Same player. What is different? Almost everything you built assumed the network was a live participant. Offline removes it. AVR has no decision to make. You are not adapting to anything. You pick a rendition once at download time and you commit. Which turns your smartest component into a dropdown. The segments land in storage. Origin private file system, or IndexedDB, or the app zone sandbox on mobile. And browser storage is not yours. It is a quota, it is per origin, and the browser can evict it. Same lesson as V1's memory drill, one layer down. And if it is DRM content, the license has to come with it. A persistent license with its own expiry. Which is why a downloaded film stops working after 30 days, and why that is not a bug. Somebody negotiated that number in a contract, and your player is enforcing it. Sixth, make it accessible. And be careful, because this is where people recite a checklist. There is one pattern that answers most of it, and it takes one line. Ship the video tag with the controls attribute. Then remove that attribute in JavaScript. Now think about who that helps. If your script fails, the user gets working native controls. If JavaScript is off, same. If a screen reader arrives before your code does, same. Progressive enhancement is not a philosophy here. It is a fallback that costs one line. Then the parts you own. Every custom control is a real button in tab order with a label. Space toggles play. Arrows seek. And they only do that when focus is inside the player, or you have broken the whole page. Caption styling is a user preference, not your design opinion. Size, color, and background come from the operating system. And a caption must never sit under your control bar, which means your caption layer has to know when the controls are visible. Seventh, you listed 15 controllers. Now draw who talks to whom and say which calls are synchronous. This is the question that catches people who memorized a diagram. A list of components is a vocabulary. The matrix is the design. And you already have the picture. It is the diagram from the end of the last video. All I am going to do is change what the lines mean. Solid line, synchronous. It answers inside the same tick. Dashed line, asynchronous. It leaves the process and comes back as an event. The stream controller is the only thing on a clock. 10 times a second, it asks one question: what is missing? Everything it touches is synchronous. It calls the buffer controller and gets an answer immediately. The buffer controller calls ABR and gets a number back immediately. No awaits in that path. The asynchronous edges are the ones that leave the process. The loader, going to the network. The license request. The demuxer, in a worker. And those all come back as events, not returns. Anything that can block for a network round trip is an event. Anything that must answer inside one tick is a call. Say that sentence and you have answered the question. Eighth, time to first frame is 400 milliseconds too slow. You cannot change the CDN. Go. There is an order to this, and the order is the answer. Preload equals metadata on the video tag. You get duration and dimensions without a byte of picture. A poster, so the frame is not empty while you wait. That does not make it faster. It makes it feel faster, which is a different and equally real win. Then the manifest. It is small, It is on the critical path, and it is usually the first thing you could have started earlier. But the biggest one is the cold start. V1 showed you the player opening with a hard-coded 500 kilobit guess. That guess picks your first rendition. And your first rendition is most of your first frame. So remember the last session. Store the estimate, seed the player with it, and a returning viewer starts where they left off instead of at the floor. One line of local storage, and you have moved the number everybody else is chasing with infrastructure. 9th, a smart TV runs your player for 8 hours. What breaks?
And not the buffer. We did the buffer.
3 things leak, and none of them are the video. Listeners. Every rendition change, every track switch, and something attaches a handler it never removes. Object URLs. You created one to attach media source. If you never revoke it, the browser holds the whole thing alive. And detached media source objects. You made a new one on a fatal error, and the old one is still referenced by a closure nobody remembers writing. Which brings us back to the only question this round is really asking. How would you know? You take a heap snapshot at minute 1 and another at minute 60, and you compare detached nodes. And in production you report it, session length against memory, bucket by device. A leak is not a crash. It is a slow decline that only shows up in a graph you decided to draw. 10th. And this one has 2 halves. First half, it has to work in React today and something else in 2 years. The instinct is to build a React component. It is the fastest way to a demo and the slowest way out. Because the hard 80%, all of V1, has nothing to do with React. So the core is plain TypeScript. No framework imports. A controller class that owns the video element, the source buffers, ABR, and the buffer. It exposes an imperative API and an event emitter. That is it. Then each framework gets a thin adapter, a hook, a composable, a service, and a web component as the fallback that works anywhere. And you can draw that boundary straight onto the machine. Everything inside it is plain TypeScript. The video element, the source buffers, the controllers, the loader. 15 boxes, and not one of them imports a framework. The adapter is a thin ring around the outside. That is the whole architecture. And here is the decision the interviewer is waiting for. Who owns playback state? It cannot be the framework. The video element is imperative and it ticks 10 times a second. Put that in a render cycle and you are re-rendering a tree 60 times a minute to move a progress bar. The core owns state. The framework subscribes to it. And this is not a clever idea. It is what hls.js and Shaka already are. Framework-free modules. The wrappers came later. Second half. TypeScript, and not for the types you write. For the ones you get. A TimeRanges that the compiler knows is a list, not a bar, is a whole class of bug you never ship. Then the question everybody wants to answer with yes. Do you use WebAssembly?
Mostly no.
Your controller logic is 100 lines of arithmetic running 10 times a second. That is not a bottleneck. WSM earns its place in exactly 3 spots. A software decoder for a codec the browser refuses. A custom demuxer. Subtitle rendering for scripts the browser lays out badly. Everything else is a rewrite you will maintain forever to save nothing. And the number that ends the argument is bundle size. I measured it this week on the current releases. hls.js is 159 kilobytes gzipped. Shaka is 265. But the number that matters is the one you can get down to. hls.js ships a light build at 105 if you drop what you are not using. On the device that needs your player most, that gap is a second. The library you pick is a latency decision wearing a dependency's clothes. 10 questions. Go back and look at what they had in common. Seeking was, how do you know the range is there? DRM was, how do you know the license arrived? Captions, how do you know it rendered? Offline, how do you know the license is still valid? Memory, how do you know it leaked? None of them asked how the player works. You answered that in the last video. And the diagram is different now. One box heavier, and every line labeled with whether it can block. That is what a follow-up round does to a design. It does not replace it. It annotates it. The follow-up round is not about the design. It is about whether you can tell the truth about it. A senior answer is not a longer answer. It is one that says how it would be checked. And if you cannot say how you would know, then you do not know. You believe. Every diagram, every number, and every decision from both videos is in the repo. Link below. Next in this series, 65 million people press play at the same time, and almost nothing you just learned survives it. This is beyond code karma. 2 videos. 1 diagram you can now draw from memory. But drawing it is not the same as owning it. So here is the last thing. This is the player. Not a picture of one. The thing itself, playing. Watch the strip under the video. For ranges, 3 gaps. You know what those gaps cost now. You know why seeking backwards is cheaper. And the counter on the right is the loop. 10 times a second, 1 question. What is missing? On the right is all of it that matters. A class that owns the video element and the source buffers. A method on a clock, asking whether the buffer is deep enough yet. A loader that fetches 1 segment and appends it. That is the hard 80%. Now look at the top of the file. It imports nothing. No React. No Vue. No framework at all. Which is the whole reason it will still be there in 2 years. And then there is this one. 2 estimates of your bandwidth. 1 fast, 1 slow. You take the lower. That is the entire adaptive bitrate decision. For lines. Most of this video was spent on those 4 lines, and now you know why.
Not an average. A minimum.
Because a bad measurement is information, and a good one might be luck. It is all in the repo. Clone it. Delete my version. Write your own. The difference between watching this and knowing it is about 4 hours. And you will not know it from me. You will know it the first time your own graph moves.